So today in this video we are discussing Linux file system root directory structure. The directory structure of the root, what are the various functions and use cases of directories that are in the root of a Linux file system. The root directory is the top level directory of the file system for Linux operating system. Root directory. The root directory, which is indicated by /, is the first directory in the file system hierarchy. Root of the file system is analogous to the trunk of a tree, as the starting point where all branches originate from. All the files in a file system have root as their starting point in their path. So what do I mean by starting point in their path? Let's see an example. So I will be opening my terminal and show you what I mean by starting point in a path. So here my terminal is ready. Let's go to the root. Cd command is used to change the directory, and cd /root here indicates root. So I'm moving to the root of the file system. pwd tells us the current working directory, uh, so it shows us that we are at the root. ls command is used for listing files that are in the current working directory if we do not pass any argument. So let's list all the files and directories in the root. These are directories and files in the root. Let's use the cd command again to move to home. Inside home we have a directory called lfa. So let's use the pwd command to know the present working directory. We are in home lfa. You can see the path name of the lfs directory starts with the root. It is analogous to the trunk of a tree. All the branches start from the trunk of a tree, and similarly all the directories path name start from the root. Now let's move to the next slide. Oh wait, I think we should first discuss what is a file system. A file system is a process that manages how and where data on a storage disk, typically a hard disk or a solid state drive, is stored, accessed and managed. It is a logical disk component. By logical here we mean that it is a software component and not a hardware component. It is a logical disk component that handles the disk internal operations and presents the human user with an abstraction of the disk. By abstraction here we mean that we do not really have to worry about how the data is being written on the disk and what type of disk it is. The file system takes care of all those things for us. Now let's move to the next slide. So this is an image by the Linux Foundation. It shows the various directories in the root of the file system. The first file we can see is bin. You can notice the / just in front of bin, which indicates bin is in the root. Bin is a directory in the root. Bin, then we have etc, which is pronounced as hc, et and c, hc. Then sbin, usr, var, dev, home, lib, menti, opt, proc, root. Now we will discuss these directories in detail in the ahead slides. Now let's move to the next slide. So the directory structure that we saw is loosely described by a standard called File System Hierarchy Standard that is maintained by the Linux file system. The File System Hierarchy Standard is a reference describing the convention used for layout of a Unix system. So these are just references. These are non-binding. We do not have to abide by the File System Hierarchy Standard. In fact, many popular Unix distributions do not abide by the File System Hierarchy Standard, or they abide by some of the portion of the File System Hierarchy Standard and ignore the portions that they do not like. It is maintained by the Linux Foundation. Linux Foundation is a not-for-profit consortium dedicated to fostering the growth of Linux. It has been made popular by its use in the Linux distribution, but it is used by other Unix variants as well. Now let's move to the next slide. Listing files in root. So ls command is used to show the files and the path that we specify in its argument. And if we do not specify an argument, it would show the files and directories in the present working directory. So here we are specifying that ls list all the directories and files in root by giving the forward slash as an argument to the ls command. Let's move to the next slide. Let's start with home and root directory. So why are we covering home and root directory simultaneously? The root is the home directory meant for just for the root user. So there are uh, users in an operating system, and root is the power user of the Linux operating system. There can be and there can be other users who are not root, and they have less privileges in comparison to the root. So the root is the home directory meant for just the root user, who is the power user, and home directory contains directories that are home for all the remaining users. The home directory is not the home for remaining users, but home directory contains directories that are home for remaining users. Root is the home for the root directory in the root is the home for the root user. Uh, let's look at an example. Let's assume that we have two users, Bob and Alice. Their home directories would be uh, respectively Bob and home Alice, if their username are Bob and Alice respectively. But for user root, their home directory would be forward slash root, and for normal users such as Bob and Alice, their home directory would be inside the home directory, and the name of their home directory would be their username. Now let's move to the next slide. Why do users need the home directory? It is a very important question. Why do we even need the home directory? It contains directories that are kind of personal space, working space for all user other than the root. There will be separate folder for each user in home directory. For example, if you have a user called Sam, then their default home directory can be forward slash home slash Sam. Only user who owns this subfolder can access its content. Other user other user cannot access another user's home directory unless they have root privileges. Only root can access home folder of all the users, and non-privileged users cannot access other users' home directory. So here is an example. So user cannot access user Barbie's home directory content, which is located at home Barbie, unless Ken has root privileges. So if Ken has root privileges, he can access Barbie's home directory, but without root privileges, Ken can only access his own home directory and cannot access Barbie's home directory. Terminal properties, command histories, application settings such as bash rc, vimrc, ssh are located in the home directory. Even if you're using a GUI Linux distribution, your desktop will be in the home directory. Home directory may also contain files such as downloads, music, pictures, etc. System admins, when trying to import for users, they will implement it on the user's home directory inside the home directory. Folders inside the home directory may be used to implement quota for users to limit the usage of system resources by that particular user. And now let's move to the bin directory. Bin is an abbreviation for binary, which means an executable file. This directory contains executables which can be executed to accomplish the task. This folder cannot. This folder contains base executables which are required for minimal system working. So bin directory According to the file system hierarchy standard, should contain only the minimal set of binaries that are required for minimum system working. This folder contains basic commands such as cat, chmod, chgrp, chown, date, dir, dd, df, ln, mv echo, zipping tools such as bzip and gzip, etc. Uh, but some Linux distributions such as Debian and other Debian-based distribution, mm, the bin directory is a symbolic link to the user bin. To the user bin directory, we will discuss about the user directory in the next slide. So, symbolic is symbolic link. By symbolic link, we mean that it points to the user bin directory, but the user bin directory doesn't contain anything inside itself, but it is a shortcut to the user bin directory. Now let's move to the next slide. We will discuss symbolic link and user bin in the next slides. Sbin directory. This directory contains system binaries or super user binaries, which are required for changing system properties or system level settings such as disk management, network management. Uh, Binaries that reside in Sbin, an example would be ifconfig or iwconfig or this folder can be accessed by normal user, but they cannot execute any of the commands located in this, and whatever command script executable are located in this folder are executed exclusively by the root user or users who have root privileges. On Debian and some other distribution, the sbin directory is a symbolic link to the user sbin, which is kind of similar to the bin directory we discussed in the previous slide. So on some Debian based operating system, sbin is a symbolic link to the user sbin, and bin is a symbolic link to the user bin directory. Now let's discuss the bin directory. So USR is an abbreviation of Unix System Resources. It contains read-only user data. By read-only, here we mean that only root can move around files or delete files in the user directory. Normal users who do not have root privileges cannot delete or move files inside the root directory. The majority of multi-user utilities and applications are in the user directory. Uh, it its contents are shareable and read-only. By shareable, here we mean that many users, let's say we have 10 users who are not root privileged, they can share the binaries inside they can share the files. We will discuss about the binaries in some time. They can share the file which are inside the USR directory, which is the Unix System Resources directory, and these are read-only. Only root can delete files inside the USR directory. Originally, bin was only for binaries and libraries required for booting, while USR bin was for all other executables and libraries. But now, on many distributions such as Debian and Debian-based operating systems such as Ubuntu and its derivatives such as Ubuntu, the bin is a sim to user bin. Similarly, for sbin directory is a symbolic link to user sn. So here we can see the example file command is used to check the file type of the argument we pass. So here we are checking the file type of the bin directory. It says that the output is bin is a symbolic link to user bin. Similarly, sbin is a symbolic link to user sbin. It is on Ubuntu, which is a Debian-based operating system. So as we discussed earlier on Debian and Debian-based operating system, the bin sbin are symbolic link to user bin and sbin respectively. And also there is another directory lib which we will discuss in the next slide, is a symbolic link to user lib. So what is a symbolic link and why do we need symbolic link? A symbolic link creates a file in your directory and acts as a shortcut. Shortcut as in the Windows, if you are familiar with Windows. You will know that we can make shortcut in the desktop or let's say Google Chrome or Firefox web browser. A symbolic link creates a file in your directory and acts as a shortcut to a file or folder. Symbolic link is a file system object that points to another file system object. Example of file system object would be folders and directories, folder directories and files. And also an important thing to note here is that all the folders in Unix and Unix-like operating systems such as Linux are files. So we can call a folder or a directory a file in Unix or Unix-like operating system. And the reverse is not true. All files are not directories, but all directories are files. Uh, a symbolic link is a file system object that points to another file system object. The object being pointed to is called the target. So the bin inside the root is a symbolic link to user bin. So here the target is user bin. Symbolic links are transparent to users. The links appear as normal files or directories and can be acted upon by user or application as if they were normal files. So to an user it would appear that the symbolic links are normal files, but in fact they are pointing to another directory. Now let's move to the next slide. Proc directory, which is an abbreviation of processes. The proc file system contains an illusionary file system. By illusionary file system, we mean that the file system doesn't really exist, or the proc directory doesn't really exist on the hard disk. It does not exist on disk. Instead, the kernel creates it in the memory, the RAM. The proc file system, proc-fs, is a special file system in Unix-like operating system. So Linux is a Unix-like operating system. That Linux de facto Unix system, but Linux doesn't have the authority to use the Linux trademark, which is owned by the Open. Linux is a de facto Unix operating system. The proc file system is a special system Unix-like operating system that presents information about processes and other system information in a hierarchical file-like structure, providing a more convenient and standardized method for dynamically accessing process data held in the kernel. We can press the proc file to conveniently access process data that are running in the kernel. The virtual files proc have a unique qualities. Most of them are 0 bytes in. Yet when the file is viewed, it can contain quite a bit of information. So we check the findings of these files. They would appear to be 0 byte, but they contain data. They would appear 0 byte because they do not exist on the data when to the files presented by the kernel as a file, but they actually do not really exist on the disk. Uh, let's see an example before moving to the next. Open the terminal, move to the proc, where we know the current working directory is proc list files. We can see files and directory the proc directory. Here we can see there are various directories with file name as numbers. These numbers are process ID for processes that are running in the operating system. You can also access various information. For example, CPU info. That's content inside the cat would print the content in the terminal. Right? Gives us information about the process. We can set it is Intel processor. before 4-bit process. The clock speed, the processor count. So the first processor, that is the zeroth processor, the number of cores, the quad core processor. So this is the second processor with processor number one. These uses zero based indexing. The first processor was zero. Second processor is one. Third processor, fourth processor could be. Here's the information. There are various other files provide similar coordinates. Next next slide. The boot directory. The boot directory holds files used to boot the operating system. The contents are mostly Linux kernel files or bootloader files. The VM Linux. It is a file that is the Linux kernel. VM Linux is the Linux kernel, and if the kernel is compressed, the file name would be VM Linux. And if if the kernel is not compressed, the file name would be VM Linux ending with X. And if it is GZ compressed, it would be VM linuz. Notice the Z in the end. The next file is initrd.img, which is a temporary file system used prior to loading the kernel. And also the grub directory. Grub stores its file at boot at the grub directory inside the boot directory. These files are mostly modules with configuration stored in grub.config.cfg. Mm. This is the list of files and directories inside the boot directory and inside the grub directory inside the boot directory. We can see we have the kernel here is compressed because the kernel here is compressed as the file name for the kernel is vmlinuz. That is Z. It ends with Z. So it is a compressed kernel, and the we can also see the initrd.img file and grub directory and mm, and also the grub.configuration file, that is grub.cfg. These files were discussed in the previous slide. Here we are just listing them and showing you that where these files exist. Now let's move to the next slide. etc directory, which is pronounced as etc, et-sw. The etc directory is where a Linux system's configuration file lives. A configuration file is a file that is used to control the operation of a program. The configuration file basically stores the setting of a program as text file or JSON file or YAML file, depending on the type of program. It is a good idea to back up this directory regularly, because let's say your computer crashes and you have a backup of this, you just need to access the program and they would automatically fetch the settings from configuration from the etc directory. So etc directory stores configuration files. It will definitely help. It will so if we back up this directory, it will help reconfiguring if we upgrade or reinstall the operating system. Normally, no binary file should be or are located in the etc directory. So here we are listing the content of the etc directory. List of files in etc directory of an Android device. So Android uses the Linux kernel. Android is a Linux device. Here we are listing the content of etc directory of an Android device. You can see there are configuration for the Bluetooth, an Amazon app, DHCPD, firmware, and various other configuration. Now let's move to the next slide. swap file. So swap file is not actually a directory but a special type of file. A swap file is a system file that creates temporary storage space on solid state drive or hard disk drive when the when the system runs low on memory. So if your RAM is getting filled or is filled, the data which is not required uh, can be stored in swap file. That data that needs to be accessed more frequently can be stored on the RAM. The file swaps a section of RAM storage from an ideal program and frees up memory for other programs which are more memory intensive. They frequently fetch data from the memory, and the program which are not being fetched as often as the other programs can be swapped into the swap file. It's actually a file and not a directory, although the directories are files in Linux. So as I told earlier, all the files in Linux are not directories, but all directories in Linux are files. Let's move to the next slide. The dev directory. Dev is an abbreviation for device. Device files example would be on dev null, dev video 0, dev sda1, dev tty, dev random. The dev video 0 can be device file for the camera of your system or your computer. Dev sda1 is the first partition of the hard disk. Dev random can be used to get random data. Similarly, dev null and dev tty. A device file or a special file is an interface to a device driver that appears in a file system as it were an ordinary file. So these are not ordinary files, but they are device files. So dev null accepts and discard all input written to it, provides an end-to-end and provides end of file indication when read from. So if you read from the device null dev null file, we will get an end of file as we start reading from. End of file is used to indicate um, that the end that the file is ended and the program should stop reading it. Dev 0 accepts and discards all input written to it, produces a continuous stream of null character, zero value byte. Zero value byte means all the 8 bits in the byte would be zero. As output when read from the dev full produces a continuous stream of null character, zero value bytes as output when read from generates and generates a disk full error when attempting to write to it. Random produces bytes generated by kernel's cryptographically secure pseudo-random number generator. Its exact behavior varies by implementation depending on the operating system, and sometimes variants such as urandom and arandom are also provided. So now we will be discussing the MNT and media directory mm, of the file system inside the root. And before we discuss those, let's discuss what is mounting. Mounting is a process by which a computer's operating system makes files and directories on a storage device available for user to access via the computer's file system. So mounting is a process by which we join in another device to the file system in the operating system so that we can access the files on the other device as if they were part of the file system of the operating system. In general, the process of mounting comprises the operating system acquiring access to the storage medium, recognizing the file system on it, reading it, and processing the file system structure and the metadata on it before registering them to the virtual file system. The virtual file system is an abstract layer on top of a more concrete file system. VFS allows client application to access different types of concrete file system in a uniform way. So VFS is a kind of is a layer on top of the actual file system on your operating system. It allows us to mount non system which are not same onto one another. so that we can access as if they were a single file system. This is the function of a virtual file system. The location in the virtual file system to which the newly mounted medium was registered is called the mount point. So the file is mounted so the directory in which the new device is mounted is called the mount point. When the mounting process is completed, the user can access the file and directory on the media from that particular directory. Mounting your pen drive, thumb drive, mounting external SSD, HDD, mounting your phone storage while data transferring are example of mounting. Now let's discuss the MNT directory. MNT is for temporary mounting. In other words, where users can mount things. This directory is generally used for mounting file system temporarily when needed. We will now let's move to the media directory, and after that we will discuss the differences between MNT and media directory. Media directory. Media is a mount point for removable media. In other words, where system mount removable media. This directory contains subdirectories used for mounting removable media such as CD-ROMs, floppy disks, etc. Now let's discuss the differences between MNT and media directory. So when we are manually mounting devices, we should use the MNT directory, and we should mount manually mounted devices to the directories inside the MNT directory. Uh, it is very important to note we do not mount. We should not mount devices directly on the MNT directory, but inside directories that are inside the MNT directory. And media, the OS will mount any new device itself in the media directory. You should not manually mount stuff at the media directory. So I think I should repeat once again. MNT, use it when you want to mount a device by yourself manually for MNT. And for media, the operating system will mount automatically any new device itself in the media directory. You should not manually mount stuff in the media directory. CD-ROM directory. So the CD-ROM directory is not specified in the file system hierarchy standard, but some distribution use it to mount CDs. Note that it doesn't actually really matter where you mount things, as the primary objective of mounting a storage device is to make it accessible from the host operating system virtual file system. So mounting is primarily used for making a device accessible from the host operating system's virtual file system. So it doesn't really matter where you mount, but it is a good practice to mount at a particular location so that you can really access all the mounted device at a single directory. In OS which don't have the CD-ROM directory, they mount CDs automatically in the media directory. So if some operating system doesn't have the CD-ROM directory, because they probably don't like the directory or because it is not mentioned in the FHS, they mount CDs automatically in the media directory, which is the directory used by operating system to mount devices automatically. Now let's discuss lib and variants of the lib directory. The lib directory contains kernel modules and those shared library images. The C program code library needed to boot the system and run the commands in the root file system by binaries in bin and sbin directory. The lib directory contains kernel modules and shared libraries that are required by the binaries in the bin and sbin directory. Libraries are readily identifiable through their file extension of .so. So uh, .so is the file extension of dynamic libraries that may be needed by the binaries in the bin and sbin directory. There may be one or more variants of the library directory such as lib32 and lib64 on systems which support more than one binary format requiring separate libraries. This is commonly used for 64 or 32-bit system which support multiple binary format but require libraries of the same name. On some OS such as Debian and Debian based, the lib and its variants such as lib32, libx32 and lib64 are symbolic linked to the user lib and lib32, libx32 and lib64 respectively, similar for uh, which is similar to the bin and sbin, which we discussed in the previous slide. Now let's move to the sys directory. Sys directory contains information about the devices, drivers, and some kernel features. Sys is an interface to the kernel. Specifically, it provides a file system like view of the information and configuration setting that the kernel provides, much like the proc. I think we haven't discussed the proc directory yet. We will discuss it. Writing to these files may or may not write to the actual device depending on the setting you are changing. It is a it is not only for managing devices, though that's a common use for this directory for the files or directories inside the system. Now let's move to the SRV directory. SRV contains site-specific data which is served by this file system. If you have a HTTP or a FTP server running, you might have files which you can use to serve data for these two services, HTTP and FTP. There can be another examples. Now let's move to the next directory. The temporary directory. TMP is an abbreviation for temporary TMP directory. The temporary directory contains files that are temporarily required by the system as well as other software and applications running on the machine. Files and data stored in the temporary directory get automatically deleted upon system boot reboot. So we should not store any important file in the temp directory, as boot the data will be deleted by the operating system. Now let's move to the next slide. So here we are enlisting the contents of the temporary directory. See, it has some temporary data. All of this data will be deleted on the next boot. So we should not store any important or valuable files in the temp directory. Now let's move to the var directory. Var is an abbreviation for variable. Variable files whose content is expected to continuously change during normal operation of the system, such as log, spool files, and temporary email files stored in the var directory. We can see the backups, cache, lib, local, temporary, snap, spool directories, www directories, this var directory. The data inside these directories are expected to be changing continuously with the operating system. The cache directory is used for caching content on the running programs in the operating system, and the log is used for logging events of the programs that are running in the operating system. Now let's move to the next slide. Also, an important thing to note is that the temporary directory and the var directory, before we move to the next slide, it is important to note that the temporary directory and this var directory doesn't get deleted on system reboot. I think there is a certain time period after which it's deleted, but it is not deleted on system reboot, but a specific time period depending on the operating system. Now let's move to the next slide. OPD directory, which is an option, which is an abbreviation of option. It holds optional software packages that you install that are not required for the system. By not required, I mean that you do not need the software which you install in the OPD directory for the operating system to boot up or function correctly. So here we can see that we have directories such as Deskreen, Google, and NVIDIA. So Google might have the Google Chrome, which we do not need to actually run the operating system, because Linux operating system doesn't really depend on Google Chrome. Similarly, for the NVIDIA graphic drivers and the Deskreen directory. Now let's move to the next directory and then to the next slide. Run directory. Runtime, it contains run variable data, information about the running system since the last boot, currently logged in users, and running daemons. Daemons are background processes that runs continuously in the background. We do not really need to care about them. They automatically run in the background. Files under this directory must be either removed or truncated at the beginning of the boot process. But this is not necessary on systems that provide the directory as a temporary file system. So all the data in the run directory uh, deleted when the computer boots. So we should not store any important data in the run directory. But there is also another type of implementation of the run directory, in which the run directory is a temporary file system. And so when we shut down the computer, the RAM gets clear and the contents in the run directory is automatically deleted because they are originally stored in the RAM, to the memory. Now let's move to the next slide. Mm, So here we are listing the contents of the run directory. Now let's move to the next slide. The snap directory. Snap directory is by default where the files and folders from installed snap packages appear on your system. Snap directory is not part of the file system hierarchy standard. Snaps are cost distribution dependency free and easy to install application packaged with their dependencies to run on all major Linux distributions. From a single build, a snap will run on all supported Linux distributions. So snap is used to install software and is not really a part of the file system hierarchy standard. That is the FHS. And here we are discussing the Ubuntu on Debian-based Ubuntu operating system. So we are also discussing the Snap directory, but the Snap directory is not part of the file system hierarchy standard. So let's move to the next slide. So this list for revision, we can see um, all the directories listed here. In a tree-like fashion, we can see the root directory, the boot directory, event directory, var directory, etc directory, media directory, home directory, husband directory, user directory, dev directory, opt directory. Uh, you can actually pause the video and try to remember what are the functions of each directory. And let's move right and please subscribe.